Today we're going to be working on. No, I don't want to do that. Today we're going to continue working a bit on the Raytracer, and I had some plans to. Sorry, I had to think a bit for a second for my brain to catch up. So I planned on working on the scene BVH. So I can actually show you what we did last stream, right? So if we go here, let me open my stream as well. Right. So we managed to create like 1,000 potatoes at once. However, it is very, very slow. So the issue here is that it's too slow, basically. If it's running one potato, it's fine. However, if we add a bazillion potatoes, then it starts getting really, really slow. However, so to combat this, I wanted to create a scene BVH that basically encapsulates the entire scene, right? So we started with this last time, and we created some basic setup for this, right? So let's go with the original BVH and take the subdivided. Traverse. No. And then take the subdivided. Right. And that can go into the scene BVH. So we have the subdivided. Right. We don't need the mutex here because this is single thread with some experience for multi-threading, and we close this, right? And then we replace this by info.models. Right. So partition still takes in model data, right? So this should instead take a SID. Yeah, this needs to be changed. So this takes in the vector, right? Oh, and this would be models. Right, and then that's changed. Okay. And then in the partition, this needs to be changed as well, obviously. Right. So that's set up for the subdivided. Now we say m.nodes info.models m.nodes and info.models, right? So the subdivided part is actually the exact same for the scene BVH and the original BVH. I mean, it's still the same principle, right? You get the nodes, you partition them in some way, and then you go left or right. So nothing changes here. The only thing that changes here is that instead of dealing with triangles, we're dealing now with models. But the partitioning doesn't really care for, or the subdivide doesn't care for that, if that makes sense. However, the partitioning here is where there is going to be a difference. However, we can stay very close here. So we take the partition. Sorry. Actually, let's close some files as well that we don't need anymore, because these are just in the way. Right, and then we pin the scene BVH as well. Pin, pin, and pin. Right. Then we go to the regular BVH, and we go to partition, and we take the code here. Right. Then in the scene BVH, we paste this. So this should hopefully work for the most part. If my guesses are correct, we would only really need to do some slight modifications to get this working, right? So this is still the same, still the same, still the same. Oh, sorry. Right. So this sort, oh yeah, include algorithm. Okay. So we need to sort. However, this takes in the triangles. We don't want to do that. We want to take in models.size. Sorry, models.begin and models.begin, right? And yeah, this would still be the center. However, it seems we don't. Right, so this is triangles. No, this would be a const rt. No, this would be what is it? A shared pointer of model. And same here. Right, and this would be const references. And then we return a dot model data dot get bounds, right? And then this would be right. We would add these two bounds together. So this would be bound 0. And then we add the bounds 1. And then we divide by 2. So this should give us the center of the model. And then we pretty much do the same. However, we would do B here instead. Sorry, and we would return this. And this would be axis. And same here. Right? And then that is now a proper sort. So the issue here, though, is that everything is in local space. What is a problem? Because we need to deal with the this PVH in world space. So I realized that here as well. What is kind of a problem, because this is takes the bounds of the box, but then it doesn't transform it into world space. However, no, I think this is actually fine. Think about it, because we can just transform. We can do all this in local space, and just in here transform. Yeah, and transform all of this into. Sure, I think that could work. Although no, that would actually be problematic. Right. Because the issue here kind of is the following, right? Because the scene PVH does everything in local space instead of world space. So when we intersect it, we transform the ray into local. Yeah. However, with this, we want it to be in world space, so we can actually eliminate things. Because by default, everything in local is at 0, 0, right? So it doesn't make sense to have everything in local. You want this in world space, but that would mean that we need to transform all the outside PVHs to world space, and then find if we hit the PVH, and then we transform that back to local space, so we can actually intersect the correct triangles. What is interesting, to say the least. Right. So we are going to need something to go from bounds to a minimum maximum. Okay. I think we have a utility header. Yeah, we have a utility here. Okay. So this would be, we need a function here that takes in some bounds and then transforms those bounds with a transform, and then it gets the minimum and maximum, right? So we can call this inline s3 vector Do I need this? I think I only need this in the BVH. Yeah, I think we can just keep the utility header as is and just put this in the bvh.cpp, right? So, sorry, CMBVH. So we want a helper function here that returns a std array of GLM vec3s and of size 2, and this would be transform bounds, and this would take a const array ref. This would be bounds, and this would transform that, right? So we'd have a GLM vec3 corners, and this would be 6. Okay, right? Corners. I'm gonna say, no, sure, this should be 8, right? So, corners.0 is equals to bound 0. Corners.1 equals bounds.0. Yeah. However, okay, so the kind of annoying thing here is that we need to put all three things individually. So this would be bounds 0.x plus bounds 1.x, comma, bounds 0.y, bounds 0.z, right? And then we would do something similar here. So this would be just the x position. However, this would be adding the y. So this would be bounds 1.y. Then we do something similar here. And this is then the same x, the same y, but then we add the z components, right? So now we got a cube with the same x position. Yeah, we're still missing 1 though. No, sorry, this is different. Yeah, we're still missing. Oh yeah, we're missing this one. Saying that correctly? Yeah, we're still missing a bunch. Okay. Right, and doing this in a convoluted way. Because I need to get all the corners, and my brain is trying to wrap around to this. So let's start with the x plane. So we have bounds. We have 4 corners on this x, right? So let me comment this out. So there's 0, 1, 2, 3, right? And this would be bounds x, 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 right? Then we would have the same y. And then, so we have 2 for the same y position. And, oh, sorry, this should all be the same, right? And comments, right? So then we have 4 on the same x position. Yeah. Then we have 2 different y's, and they're on two different Z positions. So that would be 1 and 1, right? Then we have something very similar for the other corners. So we have 4, 5, 6, 7. And this would be bounce 1 dot x, and it would still be the same y, so twice the y here, and the different sets. Right. So this is the corners of the thing. Then this needs to take in another function. This would need to take in a glm Thank you, Sven Tenebris. Yeah, is that how I pronounce it for the follow man? Much appreciated. So we take in matrix. Sorry, constant matrix reference, and this would be the transform. Okay. Reference. I hope you're enjoying the stream, man. Right. Then I got the transform. Then we need to get a glm vector 2 here, and this would be out, and this is equal to the following. That would be just this. Yeah, I'm doing good, man. I'm just streaming for a bit. Got a break from school today, or not today, but for a few hours because we have to wait for the team. So I decided to just work on my personal project a bit. What is this Raytracer? Yeah, I'm doing good. Hope you're doing the same. Yeah, let me show you what we were working on. So currently working on an entire BVH for the scene. I don't know if you're familiar with binding volume hierarchies, but they're basically something that massively speeds up the ray tracing. Oh, I need to comment this out real quick. Okay, right. And run. Right, so we can see that the ray tracer is rendering. However, it's very slow at the moment. Why? Because while we're trying to render 1,000 potatoes, and although each potato has spatial partitioning, it doesn't partition the potatoes, right? So we still have to check 1,000 potatoes individually to get the correct one, what is rather slow. So I'm trying to speed that up by doing the entire scene at once. Right. So I'm just trying to make a function to help me in doing that. So this would be 8. But yeah, my goal for this is to make a reasonably fast CPU Raytracer. Well, I think should be doable. So this would be glm min .1. Yeah, I really like the projects. I like making ray tracers. It's a fun challenge, and there's a lot of potential to improve your work there. And this would be corners.y. Transform times yeah, ray tracers are cool. I think the tech behind them is incredibly awesome. However, they're simply too expensive to realistically make, I think. In like games, for example, right? Because it's just very expensive to run. And this is CPU Raytracer, what you wouldn't ever use in games. But even then, it's just expensive to run, right? Okay, so I think this should work. think they should give me the bounce. So I think this sticks in the... Yeah, I think this sticks in the bounce. Yeah, okay. So this would be instead... yeah, this would give me... Oh, but this is the entire scene. Okay. No, that's a bit of a problem. So it would say... no, I'm actually a student right now. So I'm in my second year of my bachelor's program. So I don't work as a programmer yet, I'm afraid. Yeah, okay, right. So we do... is this a... what is it? They call it transform bounce, right? So then we would say... element.model data dot bounce, and then it would be element dot transform dot get transform, and this would be t bounce. Right, and then this instead would say t bounce. T bounce. Do you work as a programmer, Tenebris? Yeah. So what kind of games I'm play? I really kind of a diverse assortment, I would say. So lately I've been playing a bit of DayZ. I've also recently played Men at War, Assault Squad 2. I got Seas of Thieves from a friend today as well. Or sorry, I got it a few days ago, but I couldn't play Sea of Thieves with it. With him. I play Armor 3. Phasmophobia I like to play as well. It's really a diverse mix. I generally just like to play games with friends. Ah, nice. What do you study, man? Right, so this takes the transform bounce. Okay. Yeah. Bounce. Sure. Right, and then we need to go back to this. Right, so we can uncomment this, and then... Right, partition. Okay. So this takes the bounce, sure. Right, we had this sort. Okay. So we would need to get this line, the transform bounce, yeah. This line. Computer networks. Okay, that actually sounds really awesome. Is it like mainly networking or? Because I actually tried my hands once on networking, and networking was an interesting experience, to say the least. And I would like to bury that ground about a mile deep, or a kilometer if you're European like me, and then burn it, and then dig it again a kilometer deep. That networking code was not good. It was bad. Right, so this would be models. Hello, Carius. Is that pronounced correctly? Nah, I keep the chat in English. Although I'm Dutch, I prefer English. Mainly because it allows for more people to enjoy the stream, right? And I personally don't have a problem with talking English. Mainly networking with some C code and bash. Right, cool. That's actually really awesome, man. I really want to get into networking more, but it's such a rabbit hole. Maybe I should make a multiplayer ray tracer. No, that would be a horrible idea. But yeah, no, I do want to learn more about networking because I'm a game programming student, right? So learning more about games would definitely be beneficial. Right, this is still using the number of splits number here. UN32T m dot splits. I think this could be just one. Or let's just keep two. Currently doing my last school project before graduation, but need help with 2D game physics. No place where I could find some. There is actually a Discord group that I know, but it's for graphics programming, right? Or basically anything really like engine, gameplay, no gameplay, sorry, engine 3D related. I think if you, where the hell did I put it? It's a public server. Let me see if I can find it. Graphics programming. Yeah, so you have, I think it's this one. Yeah, I think it's, you have this Discord, if I'm correct. It's quite a big group of people that are interested in like graphics programming. So this is anywhere from ray tracing, rasterization, engine development, and there are a bunch of people that allow you to help each other, right? Sup, Beryl? Welcome back to the stream. But yeah, 2D physics are interesting. What I recommend if you're allowed to use libraries is use those. Libraries can help massively with 2D physics and speed up everything a lot. So this would be m.splits instead. Bounce left, bounce right, okay. Right, so we still need the center, right, okay. So if, okay. Yeah, I'm doing good, man. Just got a quick break from school. So yeah, so I work on game design, as I think I told before. And yesterday was basically the end of our current sprint. So this morning we had a meeting, and now it's basically like, well, we need the teacher for the next thing, and since like our current like section is done, we need to basically wait for that meeting. So I got like 2 hours of free time, so I decided to just stream a bit and work on my ray tracer, what I think is much more fun, right? So if there shouldn't be triangles, there should be yeah, there should be a model. That's it. Right, so if models dot model dot model data dot bounds, right? And this would be this. Yeah, then we got the bounds. Oh, that sounds actually like hell. I hope you managed to survive it a bit. Oh, right, and then we need another thing. Gilam fact3 center. And that's equal to this. This would be a bounds dot 0 plus a bounds dot 1 divided by 2.f. Now I can't speak Spanish at all. I speak Dutch and English, and that's really it. I speak. Yeah, no, I get that, and I speak, and I can understand some German, not speak it that well, and I did have French in high school, but yeah, I sucked at French and German for that matter, and so I sucked at Dutch as well. Honestly, the only language I was good at was magically English. Great was. So what is... Right, so this gets me the... What does this do? Why did I sort these? Oh, this was for the new bounce. Okay. Sure. Okay. Right, so this would give me the bounce of the model. Right, let me think real quick for this. Yeah, thank you, man. I guess it helped that I'm maybe self-taught for the most part. And I think I've kind of taken the like accent that was spoken like a lot online, right? Oh, right, okay. So this takes in the... Yeah, so we go over each triangle, and then we do the bounce thing. Okay, sure. So we don't need the vertex array here. What we do need to do, however, is we need to get this line again. No, we don't actually. Right. So we would do a bounce, a bounce. This would be 0, and this would be 1. Right, because this is outside of the loop, right? Because that is, yeah. We just simply say this is the bounds that we calculate here for the model, transform them, and then check the... Oh, we don't have to do this 3 times. We can just do this once. Because we're not dealing with vertexes here anymore. We're just dealing with the model. Then it's the same here. Then we don't need this either. And then we say instead as well the a bounce. A bounce of 0 and a bounce of 1. Right. But yeah, Carriers, I hope the Discord link can help you a bit with getting help that you want, because there are definitely some really cool people in there, and yeah. So what exactly was it that you were struggling with the 3D or sorry, the 2D physics? Yeah, thank you, Barrow, for the compliment as well. Yeah, so we do this, and then yeah, this would be models to begin. Right, cool. Oh yeah, but this doesn't work as well because I think we can actually just take this sort. I think it's identical. Yeah, I think we could just copy this sort. Oh, and this would be add info. And this would be info dot split axis instead. Right. Okay, cool. So then and I don't want this printf in here. Right. So this should actually do the partitioning. as well in here. Okay. Interesting. I think this works. This should work. I think. Because this is basically doing the exact same. However, we replaced the we made it so that it's now in world space calculated, and it's a world space, and it's now on models instead of thinking. Yeah, it's now in world space, and it's in on models instead of on all the models instead of one model. That's good. So then we have that. Then we want to traverse the BVH. So we can do the we're doing the intersect here. Okay. So this would take in the normal array. Then we would intersect. Okay. And then let's get the regular BVH and do traverse BVH. And this would return. Yeah, this would return a const triangle. Still. And this would be in here, right? And this would take. No, this would take in the vector of models. And it would take in the current node, take the array, box distance, object distance, right? Okay. So it would be almost the same here. And then we take in the BVH, intersect, and we traverse, and traverse BVH. We copy this code and put it in here. Right. However, that this should be m.nodes, m.nodes, and this would be models. I'll just replace this real quick. And this would be m.nodes. So this way we've set it up so it now calls the same traverse here, and then we intersect here. But this isn't quite correct because this goes over. Right, no, this is fine. Yeah, and then this still does the same. Okay, but this part is wrong. So if so this index, right, sure, that's still correct. So this would be models dot y dot model data dot bvh dot intersect, right? And this would take in the model. So this would be model I think it's like this. So model.get array and distance, and this would be distance, yeah, distance to triangle, yeah, right. So this would get the intersect there, and if that's correct, then we say no, we would need a triangle RT triangle pointer. Yeah, and that's this, and this is hit. And then if hit, wait, this returns a RT triangle pointer, right? Oh, a const, sorry. So if hit, then this is equal to hit. Right. No, we don't need to dereference it. Yeah, okay, cool. So now what this does, right, it will go over all the models that are in this node and then call intersect on them. And then, oh, it gets a triangle, herp-de-derp, and then it returns that triangle that it gets from there. However, I think we are making one small mistake here. Because in here, right, in the intersect, we call this with the transformed ray. So we need to get this in here. This would be in the scene BVH. And then we need to create a new array. And this would be this model. And same here. And this would be instead the transformed ray that we pass in. Okay, so that gets me the... Oh man, I'm so jealous actually of that. I really, really want to see snow again, but I don't think it has really snowed here for like years. I think we've gotten like some snow, but I mean, you couldn't really call it snow, to be honest. I think it's like 5 degrees here currently. Let me check for you. Okay, sorry, I was close. It's 3 degrees Celsius. What still isn't very warm, but it could be worse. But yeah, 3 degrees doesn't bode well for snow, right? Although according to the news, there is a likelihood throughout the country for either like wet snow or rain. Well, I think it's basically the same thing. I mean, it isn't, but it's still equally shitty. Because real snow is cool, wet snow is shitty. Alright, so this transforms it. Okay. So then, yeah, we need the intersect. So what did I do with the original BVH? I think I simply say, yeah, I simply say this. Okay. So BVH, scene BVH. Intersect. Right. And this would be, oh, this would be models. And then m.nodes 0. Right. And this just returns that triangle. So then I need to go to the scene. Where did I have the scene thing? Scene. RT scene. Right. So this has a, this is a BVH as well. Hashtag include core / BVH scene BVH. So this is a STD unique pointer of type RT scene BVH. And this is a scene BVH. Right. Then we say in the application at the very end, when we do this, so we say m.active scene. Oh, sorry, we do this at the beginning. So m. Do we have an active? We had an active scene, right? Did I not? I believe we had an active scene. Oh yeah, we had a test scene. Okay. So we say test scene dot scene BVH dot build. This would be m dot test scene dot models. Okay. Similar situation here. We don't get good snow often. I remember some. Yeah. Yeah. So I don't think we can really ski here because, you know, Netherlands, no mountains. we can't really ski outdoors. We can ski indoors though. But yeah, I think like actual good snow has been forever. I remember it as a child, right? You would have school and you would be basically free, like the entire day playing outside because it was snow, right? You couldn't like the breaks would be forever, and it was awesome. I miss those times, like the snow adventures. So we built the PVH, okay, and then in the Raytracer, right? So we don't want. I don't want to reflect here currently. I just want to. No, you know what? I don't want to do this at all. I just want to return. I just want to return text color. Okay, yeah. Okay, that's fair. Right, I thought you actually meant... Okay, yeah. I thought you meant like actual skiing. But that makes more sense as well. Okay. So now we don't need all of this, right? So we just say... we comment this out. And then we should say m.active scene dot scene bvh dot intersect, and this would be m.active scene dot models, then the array and hit info dot distance, and then we need to set this information as well. So then if hit info, no, we can just do that, yeah, no, let's do it in here. Hit info dot hit, then we want to set this information, right? So this would be, sorry, this would be hit info dot hit triangle. And then we actually need to check for this. So if that's hit, right, and then that is local hit, but we don't have that yet. We don't have this either. We don't have this either. Does this matter? No, because no, the material does matter. Oh, but this doesn't actually give us the model. Okay, that's a problem. Right, so we can't do the material at all. Okay. Or at least not at the moment, right? So we can't do text color here either, because that requires the material. So what we can do instead is simply return red, right? So fingers crossed this gives me the scene running. Or it crashes, of course. Exception thrown, interesting. How did that throw an exception? So there are 1,000 models, yeah. So the nodes are this. So what is number of? Let's say UN32. Ah, interesting. So this should be a UN32 as well. So how does that crash? Right, so notice is this. Wait, what? How does that crash? I'm setting it here to... Oh! Wait a second, yeah. So in the scene, we would be able to SD make unique RT scene BVH. I don't think it's actually constructed. What would be, you know, problematic. So let's run this again and see what happens now. Yeah, there we go. It's 0. Okay. Run. Okay. You know, I would call a win on that, but I am honestly not sure. This doesn't look that good. But what I can do... Ooh, that looks even worse than before. So how long does this BVH take to build? RT timer. You can include quarter timer. Timer. And then I want to printf the time it takes to build. As a scene BVH. So with this, and then I want to do printf percentage f, and then a /n, and this would take timer.get elapsed time in milliseconds. Right. So how long does this BVH take to get build? Because I think it might still be too long. Actually, I think this BVH takes too long to construct. No, never mind. This BVH doesn't take too long at all to construct. So apparently this BVH takes like less than a millisecond to build. What is perfectly acceptable. Because we have 16 milliseconds in a frame, right? Oh, it should look like the clump of potatoes we had before, right? So there should be like a circle of potatoes. However, it seems we only have, you know, a rough, like a quarter. Although, like this part, it looks correct for the most part, though. Like, let me move the... I can't run it like this. Okay. Let me go back to the Raytracer. Sorry, application, and turn this down to something usable. So I can actually debug this a bit. So we don't want 1,000, we want like 10. 10. So they should give us 10 potatoes, and that should actually run reasonably. Right. So you can see it's a quarter, right, that we're only getting. However, the quarter that we are getting, like these are definitely the potato shapes, right? However, we can see that like there's a sharp line here of where it simply cuts out the model. And the textures and stuff aren't working at the moment, what is fine. We'll get there. But the harder issue is why this isn't, why this is cutting off. So there could be a few reasons for this. One, the bounce thing is wrong. So I'm just going to start with checking out the root node. So in the scene BVH, yeah. Let's start with the bounce. So we go over all the models, right? And let's put this to debug. And then see what kind of values we're getting for the bounce. So minimum is pretty good. Oh. That's interesting. So okay, so the minimum is correct. Or we can assume the minimum is correct, sorry. But the maximum is clearly still wrong. That's interesting. Okay. So I'm guessing this T-bounce is wrong. So let's see what T-bounce look like. T-bounce, right. Okay, so that's still infinite. Okay. So that means that most likely there is something wrong in here. Oh, there we go. I see the issue. This should have been max, because we're getting the minimum maximum, right? Hopefully now we see the entire scene. Perfection. This is exactly what I expected. So there are no shapes here. That's actually great. Fuck. Right, so let's put a breakpoint here and see what's happening. So out, what kind of values are we getting for out? Z is 40, okay. Minus 6, minus 11. Sure. No, I'm willing to believe that. Sure. So if we go here, yada yada yada. Oh, it still has that. So in here. So the bounds now are from minus 35 to 9. Sure, that seems correct, and it's from y minus 33 to 25, and the z is from minus 45 to 52. This seems reasonable. This looks correct to me. The values. That's roughly what we should be expecting from the BVH, because it's very rand within 50, right? With a radius of 50. So that means we should be roughly getting like bounds 50 by 50. But it's only 10 models, so the sample size isn't perfect. So that looks correct. Then the box size here. Yeah, sure. Yeah, that's the box surface, okay. So what bothers me now, though, is that we're not seeing anything. Well, before we were seeing anything. What kind of irks me, but that's fine. Max, yeah. Sure. Then we sort of... Oh, wait a second. We're not using B-bounds here at all. Okay. So we weren't actually partitioning correctly. That makes sense. Let's see if this gives me anything. No. That's a shame. Ooh, it's really not liking debug. Wait, this... I put the thing in... Yeah. Yeah, I wish it that would work. Yeah, it's in milliseconds. Okay, so that's 1 millisecond. That's fine. In debug. So now this is being used. B bounce, transform. Yeah. Bounce. Okay. So the intersection might be wrong. Okay. So there is the intersect, right? And then this calls for first BVH. Shit. Do I ever seen BVH? Do I ever have this happen? Do I ever hit anything? No. Do I ever have this happen? Yeah. So what kind of count do we have? We have one. Okay, one model in the node. Okay. So right, index would be 9, sure. Distance. Then we get this transformed ray based on the model. Oh, yeah. Wait a second. This shouldn't be models.y. This should be models.index. Yeah, because it's the index, right, that we care about. So let's see what this does. There we go. That's some potatoes, I guess. At least we're getting something on screen again. Not a lot, but it's something. So we get models with index, yeah, we intersect it, and then we pass in the transformed ray. Okay. And then the distance to triangle. What's infinite? And if that listens to object distance, we say that's, yeah, cool. So, okay, we're still, oh, yeah, you know, we can't actually do this anymore. Because what's happening here, this is in local space, the distance. So we need to put that back to world space. Right. So we need to go to application. Sorry, no, Raytracer. Then we have this. So this is the local hit. Then we have the world intersect. And that's this value actually. So if hit, then we do this. Uncommons, 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 uncommons. Then we say this is the distance to triangle. And then we would have the model. What's this? And then distance to model is this, right? And then I need to fix this atrocious spacing. Right, so now we actually changed it so that it goes back to world and gives me the actual distance in world space. Okay, that doesn't change anything, but that is important. So there's still something wrong. For sure. Okay. So what I find interesting is that there is a sharp cutoff, right? That's something that immediately captures my attention. Because normally a sharp cutoff is an indication with the BVH that there's something going wrong with the nodes. So, yeah. However, we can't debug that in release, what is a massive pain. However, it should run fine in debug. So let's go back to here and then put a breakpoint here. Okay. So we have bounds. What are the bounds? Minus 35, 10. Yeah, okay, no, those bounds look correct, right? So let's go through the let's just run it and see if we can spot anything. So it's rendering, okay, so cool. We can see the cutoff. So let's go through just through the traverse, right? So we have the traverse, okay. Then we go in there. Stupid breakpoint. Yeah, please go in. Okay, fine. So traverse be fade, right? So we do if current node intersects. So what is the current node bounds? This would be the root node, right? So then we say this hits, sure. So is this still the current node? Yeah, okay. So if the count isn't 0, so let's check this. The count, so the current node count, as you can see here, is 0. So this code doesn't fire. Cool. So go to the else. So if the distance to the left box, distance to the right box, and some other things, right? So we check if we hit these nodes. Okay, we don't hit any of them in this case. So we do hit the root nodes, however, we don't hit any of the other ones. Stormfox, thank you for the follow, man. Means a lot to me. Right. So let's check these nodes out. So this node. Sorry, we have the. Okay, yeah. What we can actually do is we can do in here. Yeah, let's do this. A bit tricky. Yeah, I'm trying to expand this a bit, right? So we have this, and then we have m.nodes, and there's a trick here. What we can do. No. Come on, Visual Studio. Oh, sorry. Yeah, add watch. This nodes, and then we can do. I think it would be 21. Oh. Ah, shit. Let's just remove all of these. Nodes to watch. And then, oh. No, sorry, wrong value. Locals, this, dot nodes to watch. Right? And then we can simply say, this is actually an array, so we say 21. And now we have all 21 things in here. Fox, or Stormfox, how are you doing, man? However, I think we can actually do the following as well. So add this to the watch. Add watch. Yeah, that works as well. Okay, that's actually better. Because this will give us the better ones. Okay. Oh, where did it go? Yeah. Okay. So we have these. These are still false, false. Okay. So, and I want to add the current node as well to the view. So add watch. Okay. So we can see that these bounds are the following size, right? No, I think the collapsed view is fine. We can just check the x. So this one is minus 3425, what would be acceptable, and this one would be minus 35 till 10. Okay. Interesting. So it almost looks like there's something wrong with the partitioning here. To me. However, we can still check the because they both, yeah, this one starts very, very much to the left compared to this one. Like, this is supposed to be the left node, right? But why is the right node further to the left than the other one? That kind of hints to me that there's something wrong. So we can check the axis as well. So this is, oh, you know what? That might actually be fine. It might be splitting on the Y actually. What am I saying? So this is to 25, and this would be to like 25 as well. Okay, so maybe it's on the Z. So it would be minus 45 till 2, and this would be, yeah, from 10 till 50. Okay, so it's splitting on the Z actually. Sorry, my bad. So that would be, this might be fine. This actually looks like a decent split. However, it seems that we're not hitting these nodes. What's interesting? Oh. Wait a second. No. So these should be in world space as well. You know, I think that's fine. So does this ever happen? So if left shape or right shape? Yeah, no, it must, because otherwise we don't have a shape. Let's go a few more. Let's see if this ever just triggers. You know what? We can just do the no, sorry, it's the so if hit left. Let's put a breakpoint here and here. Yeah, that one. Okay. So this hits, right? So the right shape is the right node is actually hit now. So we can see that this is false, this is true. Okay. So we can see now these nodes. So if the current node is between -55 and 9, and these nodes do stuff as well. Right. So these, yeah, we shouldn't have to transform these because the boxes should be calculated in world space. So that's fine. The only place that we change things is in here, where we need to go to local space to actually intersect the scene model. Right. So this intersects, right? And then does this ever get triggered? So if left shape, okay, that does get triggered. Okay. So this gives me a actual triangle that we hit. Sure. Okay. You know what we could actually try? We could just say in here, if we hit something, just say it's that. Because this will lose our depth information. However, it would preserve everything else. What's fine. Well, it isn't fine, but it would help with debugging, right? Because what could happen, so if objects are now behind each other, it will pick one of them to render. But I wanted to see if that would get me the entire thing, but it doesn't. So it's not that we're doing something with distancing wrong. It's a bigger problem. Okay. So if we hit the thing, yeah. So if left, right, no, but this should be all okay because this is all the same code as before. So what I think is more likely is the fact that there are just simply other problems with partitioning. Although on the other hand, I can check the what kind of ray we're getting. If it's a ray to the side, it might hit the main box, but then it has a hard time hitting the other ones. But seeing, actually going back to the project, let me, yeah, there's a sharp cutoff. So that would suggest to me rather than a issue here, it's an issue with the partitioning. Because especially this part is essentially the same. The only thing that we changed here is that it calls the, from here, so if we hit a root node, we pass, we intersect all the BVHs from there. But the actual traverse is identical for the rest. So I don't think this is where the issue lies. I think it's rather with the partitioning. So let's take a look there. So the subdivide is fine. I can guarantee that because the subdivide is literally identical. So it could be in here. So this split index is not used. Let's reassign an all paths. Okay. So where do we use this? We never use this. What about the other BVH? So we have partition, partition, partition. So the split index. So where is this used? Right, so it is printed out here, but it's nowhere else. Okay, sure. So this is just complaining because I took the printf out. Sure, that's fine. So let's get over this. So we have the cost, yeah, sure, and then we have the axes, right? Distance would be the bounds, yeah. Yeah, so we would partition the, let's think of this, right? So let's say we pass in the roof node. The bounds are already in world space. Then we get the distance to those points. Then we sort them. Oh, wait a second. I might have made a loopsie. I might have found it. No, okay. I really hope that was it. So this should give me the center. Right, so I wasn't using B bounds at all. So then we take the rest of the models, right? And then we simply go over them. Then this gives me a model pointer. We get the BVH bounds, transform them to world space, and then we say bounds A, 0 and 1, just add them up together and divide them by 2. That will give me the center of the node. Right, so yeah, let me explain this real quick. So a BVH node is basically right. So let me actually start over. So a bounding volume hierarchy is basically a hierarchy of volumes, and these volumes can either contain volumes or they can contain objects. Right. So that is basically a node. So a node can either contain other nodes or it can contain models. So what I'm trying to do is I start with one big node, right? The root node. That I need to subdivide into 2 nodes. And then I go down till I end up with only models, right? In the final node. If that makes sense. So yeah. But it seemed that this is like a function that sorts it on the axis. However, we were only taking an A, so this will now actually take both in, so both bounds, and sort them correctly. So we only have 2 splits. Yeah, was fine. Then we say, okay, then from bounds, yeah. Then we go over all the models, yeah. So this is model data bounds, transform, yeah. Then the center is this, yeah. And if that center.x is less than the split points, what we calculated here, then we do min max and increase the pivot. Okay, that should be correct. Oh. No, this is still 8 pounds. Yeah. Oh, wait. No, this is still fine. I'm stupid. So then we do bounds right, okay. then it still does the same thing here. And the splitting cost is this, then yeah. And then let me check if this does anything. So it did change this to be, this should be fine. This is taking A bounds, and this is B bounds. Okay. I really hate BVHs. They're such a mindfuck to work on. But once this works, this should give me a massive speed up in performance. However, although right now it doesn't seem like it. So I'm actually curious how fast this runs in release currently. Just, not that it's a very accurate number, but I'm just curious. This is only running in about 6 FPS, what to me seems very little. Because without the BVH, we were getting, like, with 10 models, we were getting way higher. Interesting. But it could be the overhead of the BVH. So I'm kind of curious. If I do a single node, so let's say 1. So this is 25, okay. And this is a single node, that works fine. So if I do 2, I think it should be VHA. I'm just playing around with some values, see if I can... and then they're gone. Okay. This is actually much debuggable. So let me just rerun this to see if this is reproducible. If it's always with 2. And this kind of looks like it. Okay, now this is actually good. Because we can say that, hey, with 2 models, they disappear. So although I don't exactly know where they are, I can kind of safely state that there's something going wrong here. Okay. So let's run this in debug, just so I can, well, you know, debug. Right, let's see this render. Okay. So then in the scene BVH, the first thing, this can go a bit down so I can actually see what I'm doing. I am curious about the traversal. So partition, no traversal. Right. Do we ever hit something? I'm guessing not, right? However, we do reach this part. Right. So this is a leaf node that we hit. However, this didn't hit the model. So what we can check is what is the current node bound. Just to so this is minus 18 to minus 6, okay, that's fine. Minus 19 on the Y to minus 11, okay. And 40 to 48. That should be okay. And this contains how many objects? 1. Okay. Right. So this takes in the model index and the transformed ray. Okay. And distance to triangle is infinity. Okay, so let's go into this intersect. And this is infinity. Okay. So this is the right. interesting. So this triangle is not pointer. Okay. That means we don't intersect anything. Okay. However, this came from here. So what if this is wrong, this part? No, it's just the array direction and the array origin. Okay. Okay, you know what we can try? So if we say hit left or hit right, no, you know what? Fudge it, we can just do true. So if we just go through both nodes anyway, right? It's not performed, but I'm just curious what happens. We're now forcefully going through both nodes. Okay, we don't hit anything. Interesting. Oops. Oh, yeah, see ya, Beryl. Thank you for joining in, man. It was good having you around. Okay. So this green is green. What is gray? Does the intersect? No, the intersect doesn't do anything magical. Okay. I'm actually curious. So it, it does actually hit the left or right node sometimes. Does it ever hit the right node? It does. Does it ever hit the left node? It does. Okay. So that potentially would be fine. So the entirety, right? This is all in world space. Then it calculates the things. Then it goes in here. And it goes over the triangles, or sorry, the models in the final node. And then it will move this to local space by transforming the array. Then we say models.intersect, and then we pass in the model as a reference. And we pass in the transformed array and the distance. And then we do some other magic to say, but however, this hit never fires. What's interesting? Because what should be happening, right? So if it hits it in world space, it basically determines the actual world positioning and stuff. Then it gets transformed to local, where the actual BVH is built, what should be fine. I can double check what I did in the Raytracer, because it should be the same, right? So we go in here, and we take the model ref, which is the current model. Then we do this is literally copy paste. Then we create this array. Yeah, and then we just pass in this, right? Okay. Why doesn't that work? Yeah, we do pass in it. Yeah, just double checking. Is this origin direction? Okay. And then if hit. Okay. Then does this. But we never hit it. What is interesting? So I can double check if this is. Alright. I'm just thinking. I'm just thinking how sure I can be that my bounding volume hierarchy is correct. So let's check these nodes out. So we have 4 on the X, then we have 2 different Ys, 2 different Zs, okay? Then we have 2 different, then we have the other X, and then we have 2 y's, 2 z's. Oh, that's fine. Now we have infinity, 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 minus infinity, min, max, out, out. Yeah, and this is a position, so it transforms the corners. Yeah. Sure. And then it gets the actual bounds. This should be okay. So we can check the there is the, oh, we need to debug for that first. Yeah. We would go the, we need the, what is it, transform. Traverse PVH, right? There we go. Then I want to go to the part where this happens. Right. So we have these nodes, where current node should be the root node, right? So this is minus 34 to minus 6, minus 34 to minus 6. Oh, sorry. This isn't the, let me extend this, right? 1. So this is minus 19 to minus 6, and minus 25 to 45. Okay, that should be okay. And then this should be both leaf nodes. Okay. So the bounds here, right? This is minus 34, y minus 13. Okay, minus 13. Interesting. And minus 7. Yeah, what's the max height? And the z is minus 14. Okay. And what is the right node then? This is minus 18. And this was minus 34. Okay. Yeah. To minus 19.14. Okay. And then, sorry, yeah, to Z50. That's right. That's in this. Yeah. So this would be, I think, a Z split. Most likely. Yeah. I think this would be a Z split. Yeah, because we can see this is 40 to 80. Okay. So this would definitely be splitting on the Z. Sure. So this box is still considered valid, I believe. Minus 19, yeah. Okay. But we don't intersect with them. There, okay. Interesting. Very interesting. So the node themselves seem to be correct, right? If that makes sense. Right, let me explain this. So the node should be in world space be between minus 50 and 50. And they seem to roughly be. Normally it would be a bit more accurate, but we're only having 2 nodes. And sorry, 2 objects. So that means that, thinking, right, 2 objects, right. Um, yeah, we don't have a perfect spread. So it's roughly between 50 and 50. Sorry, minus 50 and 50. What is happening? And these values seem like they could contain a potato, for sure. Because the potato isn't that big. And we can say here, with the left node, X is like minus 35 to minus 20, so like 15 units, which is reasonable. In the Y, it's like 5 units. And on the Z, it's from minus 25 to minus 14, so 10 units. That, if it's rotated, that would be reasonable, like, potato sizes. Like, I'm pretty sure the partitioning is correct, because those values seem actually really, really reasonable. Those look like the values of a potato. I can check the right node as well here, if you want. Right. So this one is from minus 18 to, so about 12 units again, 8 units in height, and 8 units in depth. So these are two smaller, much smaller nodes than the root node. That's very big, right? So that would indicate that the partitioning is working. The intersect here should work just fine, because this is just a box intersect. Nothing special is happening here. And we can see that it gets here. It intersects it. However, this never intersects. Like, this never returns true. However, we can check here, right? So does this ever happen? Right, so do you ever get here? Wait. Huh? Wait. Right, so we intersect, we traverse to BVH. Yeah, I was about to say, why wasn't this triggering? Okay. Right, so I'm guessing this never happens? This does happen. So I'm guessing this happens all the time. Yeah, that's null pointer. Okay. So what kind of... Yeah, this makes sense, right? So it's supposed to be 100, however, it's like translated by 19 units or something. And the X is translated as well, quite far. Interesting. Transform, BVH, no. Oh, it's model data. Okay, that's kind of a pain. Okay. So this, we never hit this node in the first place. Like, this never happens. So we always miss the actual node. But it's very peculiar. Okay. But no, this helps me narrow it down at least. So in the scene BVH, we have this. So if the ray origin is at 0, 3, 100, right? But the transformed ray origin is 91 minus 22, 81. What strikes me as odd? So models.index. Let me add this to watch so you guys can see it as well. Add watch. Alright. So this, let's close this, close this, close this, and this. Right. So this model, right? Pointer, transform. So the position is minus 26, 12, and 20. So the inverse as well should have here a value of like 6, 3, 34. So how is this origin magically ending up with 91? because it shouldn't move the x that much. I think. So the transformed ray origin, right, is ray origin. What is 0, 3, 100? And then that inverse was what we said it was, right? Yeah. Okay. Matrix vector multiplication. So let me just double check this. Multiplying a vector by matrix. Right. So we have a matrix here, yada yada yada. No, this isn't really that useful for source. Matrix multiplication. Hoping Wikipedia can shine some light on this. I could just probably better Google it. Vector 4 times vector VM of 4. Yeah, so right. So matrix times this, right? So that would mean that the matrix yeah, right. So that means that the x here is equal to yeah, so it's all multiplied by Vx, right? What would be according to this source. So the ray origin, it's 0, 3, 100, right? So matrix multiplication is like row 0 dot x times Vx, what's 0, plus another x times 0, then plus another x times the yeah, so this would be just plus in the end the x mentioned here for the inverse. So the inverse, the x here should just be equal to 6.73 because the x here is 0. Yeah. So why is it equal to that value there? That's not what should be happening. Because yeah, the y should be 34.66 and the z should be 34.66, yeah. And the transformed ray origin is something completely different. Or at least, sorry, the x, no, the x, sorry, the z and the other one are going to be different. But for the x, it shouldn't be happening because the ray origin, right? Just to come back to it, it's 0. So multiply, yeah, this is 0. This is, oh. No, wait a second, I'm definitely doing it wrong. So it's plus m1.vy. Yeah, and we do have a y here. And we have a z as well. Okay. However, m2.x. Yeah, no, we have values there. Okay. So this would potentially actually be fine. Okay. Never mind. So we hit this one in world space, but we don't hit it in screen space at all. What is odd? Yeah, because it's very old, right? No, there's definitely something wrong here. Because, hear me out, right? This is the same node, but transformed. Where's the model with transforms taken into account? Oh, but the node isn't going to be the exact same. Because it's rotated. Interesting. You know, I'm gonna need to take a break here, I think. Because it's going to be time for me to head to school again. Or, well, not head to school, but re-attend school in about 15 minutes. And I'm going to have another great day of meetings. So, I think I'm just going to let this be here for today. Or at least for now. Because I'm noticing I have trouble focusing in the first place. Or at least, like, I've been streaming for about 2 hours now. Focusing is becoming harder, I should say. So I'm going to keep this here. And I want to thank you all for joining the stream. If you want to keep being notified for the stream, I would recommend to follow. I will be probably streaming tonight again, but that probably won't be the Raytracer. That would be, according to the schedule, Sea of Thieves with friends. So if you're interested in seeing that, do follow. And that should be streamed around, I think, 6 or 7 p.m. my time. So that would be around 12 American time. Anyway, thank you all for watching and have a good day.